Hello, students. Welcome back. And let's begin with our learning from the concept we left in our previous video. In our previous video, we talked about the concept of consumption and we talked about the pictorial presentation. We talked about the schedule, the picture, the diagram, the slope, how to showcase APC and MPC on diagrams and what are they, and their numerical representations. This way we talked about the formula or the function of mathematical expression of consumption function. So let's begin today's lecture with savings function. Savings is the counterpart of consumption, right? It's beautifully clearly given here that income is nothing but a sum of consumption and savings. So how do we define savings? Unconsumed part of income is savings. Means as in this way, I am defining it as Y minus C. Unconsumed part of income is savings. So the functional relationship between these income and saving is called the saving function. Right. Do we remember that we had this tabular presentation of the relationship between consumption and income? So if we simply subtract this C from Y, we would land on S. So 0 minus 20 gets you minus 20, and here 150 minus 140 gets you positive 10. So this is how we have derived from a table of Y and C, the table of Y and S now. The most important point to be noted here is initially the savings are negative. Eventually they become 0 and then they become positive. So here when we talk about savings, minus means if you are able to recall, this was our C and this was our Y. So I said this is this saving zone and this is saving zone, and here this is BEP, the break-even point where the consumption is just equal to income, right? On a very comparative note, it's relatable that till we are saving, we are having our savings in negative. When we have our BEP, where we are neither asking for or neither we are saving. So it is the consumption is equal to income, hence savings here are 0. And the third stage is when we started consuming less than the income, we started saving. So the savings are positive. So in this way, there are some points of observation. The very first point is S is initially negative, then S increases as Y increases, and it becomes 0 and then it becomes positive. But the most important point here, positive never means S can be any value. S has to remain lower than Y because you cannot save more than what you earn. So S has to be lesser than Y. Right. The diagrammatic presentation will make it all the more clear to you. Right. This is saving function. Savings begin with negative of y-axis as consumption started from the positive of y-axis, right? So in the later on pages, you would find there is a close relationship between C and Y, and we can derive C from S and S from C. So C and S are correlated to each other. We'll show the same. So as per the previous schedule, we are able to show that savings are initially negative, then they become 0 and then they become positive. So this area is dis-saving and this area is savings. When we have positive savings, we call it savings. And when we have negative savings, we call it dis-savings, or we do call it borrowings. Right. So let's proceed further. This has been, all these 3 points are already talked about. And then again, the slope of S line and slope. What do we know about the slope? Slope is the rate of change. This is a universal definition, rate of change, right? So slope of C means rate of change of C. Slope of S means rate of change of S. And whenever we say the rate of change, the change on y-axis with respect to the change on x-axis is the standardized formula. You can use it anywhere, and you have used it in 3-4 chapters in microeconomics study as well, when we talked about IC or PPC or the market budget line or whatever. Right. So when we talk about the slope means the delta S by delta Y. Why delta S? Because savings are shown on y-axis. Slope of S function or S line is delta S by delta Y. Change in savings with respect to change in income. Savings are shown on the y-axis, whereas income is shown on the x-axis. So here, how are the savings changing with additional income? Right. So we can find from the previous table also like this, like for every change of y, there is a change of s. For example, when y is changing from 100 to 150, it means the change in y is 50. Whereas the change in s at this level is 0 to 10. So the change is 10 minus 0, that is 10. Hence, we would say that MPS would be delta S by delta Y. As S is a straight line, so MPS means the slope remains constant all throughout, and this is the value. So here, as it is showcased, from 100 to 150, S changes from 0 to 10. So delta S is 10 and delta Y is 50, and hence the value is 0.2. What does it mean? It means out of 10 rupees earned, 2 rupees would be saved. Out of 100 rupees earned, 20 would be saved. 1000 rupees earned, 200 would be saved. So it's a relative value. It's in a percentage form. Whatever is the base value, that percentage would be calculated. So now MPC, MPS, APC, APS, these all are different concepts. As we've talked about APC and MPC, similarly, we are now to talk about MPS and APS. So A is absolute and M is relative. So this is absolute value. And this is relative or marginal. Marginal means we are talking about change up and down. And here we are talking about the main value. Means what portion of income is saved, that is absolute value. And what portion of additional income. So whenever we are talking about MPS, we are talking about the additional savings out of additional income. So these two are different. Slope of S is constant, so that MPS is constant. We have already read previously also, for a straight line, the slope is constant. Now let's talk about algebraic expression of S function. It's beautiful. S is minus C bar plus 1 minus B into Y. Now, what does that mean? How has it come, and how can we derive it from C function? C is equal to 20 plus 0.8y. What does this mean? It means that whether we have any income or not, 20 would be spent for sure. And this is called autonomous consumption. On a very similar note, when we talk about savings, so at this point of time, when we are consuming 20, where we do not have anything, any earnings, so this is saving or borrowing. So that's why the same value 20 becomes minus 20, means this is corresponding to that level where y is equal to 0. This is point 8, and what was it? We talked about this point as B or MPC. It means the propensity to consume, and that is point 8. So this becomes the propensity to save, and that is 1 minus point 0.8. Hence, it becomes 0.2. So there is a relationship between these two. MPC plus MPS makes 1. So whatever is left out of 1 after subtracting this becomes MPS, right? So for any other example, say C is equal to 40 plus 0.7y. What does it say? It says that whether you have an income or not, you would spend, the economy would be spending 40 units. And afterwards, whatever is the income generated, 70% of that income would be spent. On a similar note, if we want from this C, can we derive S? Yes. We have to just do two things. First component has to be given in the negative format, that this is saving or borrowings, and this has to be subtracted from 1. So this becomes 0.3y. So savings function has got this as savings, this as MPS as a part of the income. Moving ahead, now the question is, how do we derive pictorially C from S and S from C? So, C. Even whatever is given to you, put it at the top, and whatever is to be derived, put it at bottom. So the question in board is asked, anyways, from C we can find S, and from S we can find C. So let's see. Basically, these two are related by two things. One, the break-even point, and one, the autonomous consumption. And we have to make note of that. I'm gradually, slowly trying to make here only, and then we'll try to elaborate the diagram. Say we are given this C, and we are y can anytime be drawn at an angle of 45 degree. So if this is the given function as it is given here, I would always suggest that always try to give a flatter curve that will help you have more precision instead of giving such steep curves, right? Flatter curves will always help you with the right concepts and right expressions. So how do we go about? We can draw it S on this very axis, or we can make separate diagram. I'm making it on this very axis. So just check how much is this value on scale. This is C bar. So on scale, whatever is its value, you just keep it down below the x-axis on the negative side of y and mark it as minus C bar. So this is my first point for savings curve. Then what next? This is break-even point. And break-even point, why? Because here whatever we are earning, we are consuming. It means the savings are neither positive nor negative. Neither we are asking for nor we are able to save. So we will drop this point down, and this point gives us the value where S is equal to 0. And this is nothing but the break-even point. Using these 2 points, just draw a line and just keep it here only, and this is your saving curve. I hope this is clear to you. Now let's try to make it other way around. If we are given the savings curve, how do we plot the savings curve? Savings are plotted this way, where we begin with negative, we bring it at 0, and then savings become positive. So how do we make, or how do we derive C from S now? whatever way I'm telling you, these becomes all are the steps of making. So steps also are required while presenting the question along with the diagram. So you just make this way and you write this way. First of all, S curve is given to us. We measure minus C component here and we make exactly the same value above 0, right, above origin, and this becomes C bar, the autonomous component, right? So 1 point is received. Now we have to make a 45-degree angle, that is Y line. So this 45-degree angle has to now draw a line parallel to y-axis, and this is our second point from which S would be passing. So from C would be passing. So using this, beginning from this, make a line which goes through this point and this becomes C curve. Hence, we are able to derive C from S and S from C. What are the two most vital components? One, we need to have C bar or minus C bar in both the cases. And second, we need to make 45 degrees AS or Y line. So it means we would make use of the concept of break even point. And that's how we proceed. Now, a small or last concept for this video. What is the relationship between APC and APS, MPC and MPS? You must understand both of them together make one. Do we know Y is equal to C plus S? Yes, income is either consumed or saved. So if we divide both the sides by Y, I am dividing both the sides by Y. What does it give? Y by Y becomes 1. This becomes APC and this becomes APS. Hence, we say the sum of APC and APS is equal to 1. On a very similar note, if we have any additional income, so that will result in additional consumption and additional saving. So if we try to divide this, both the sides by delta Y, what are we going to get? This becomes 1. So 1 this is 1. The left hand side is 1. This becomes MPC and this becomes MPS. Hence, we are done with this relationship that APC and APS together make 1. MPC and MPS together make 1. And that's what is going to be used in numericals. And that's how we actually found the relationship between C and S function also, where S was equal to minus C bar plus 1 minus BY. Why did we write 1 minus B into Y? This 1 minus B is nothing but MPS. And what does it show? That B, and this B is MPC. So this clearly shows that MPC and MPS is equal to 1 and that we are using very often here and would definitely be used in the numericals also. So this is showcased here. MPC, MPS is equal to 1. APC and MPS is equal to 1. And now, after this, we are done with the first segment of determination of income and employment. We are done with chapter number 7. So see you in the next video. Over for now. God bless and have a good day. Bye-bye.